Good morning students. Vikas Global Institution Jangareddigudem. So last class I started about the thermodynamics in chemistry. Thermodynamics. So it is a branch of chemistry. It is a branch of chemistry which deals about the energy changes. Energy changes in chemical reaction. It is a branch of chemistry which deals about the energy changes in a chemical reaction. What are the energy changes? The chemical energy is converted into electrical energy converted into chemical energy or mechanical energy. That any energy converted into one form into another form, that is called energy changes. So finally, thermodynamics is the branch of chemistry which deals about the energy changes in chemical reactions. And next one, terms. What are the terms involved in the thermodynamics? Mainly the two terms. One is the system. Mainly two terms. One is the system and second one surroundings. One is the system and second one surroundings. What is the system? It is a small part of the universe. It is a small part of the universe. Some observations are made. Some chemical reactions occurred. That is called system. Okay. And surroundings. Remaining part of the. This is the system. The remaining part except system కాకుండా remaining part మొత్తాన్ని ఏమంటారంటే surroundings అంటారు. Okay, clear? So what is system? It is a small part of the universe. Some observations are made, that is called system. And surroundings except system, remaining total part is called surroundings. Okay. And finally universe is equal to system plus surroundings. That is called universe. Universe is equal to system plus surroundings. And next one, types of systems. Last class is the types of system. Types. So types are mainly three types based on the energy and matter. Based on the energy or matter, or both are exchanging between the system and surroundings. The systems are mainly divided into three types. One is the open system, and second one closed system, and third one isolated system. Open system, closed system, isolated system. What is the open system? It depends upon the both energy plus matter. That is called open system. All living human beings are present. Example is the all human living organisms is called open system. Or we take the one cup of coffee. It is placed in the any table. It is a hot cup of coffee. Hot coffee. Okay. It will transfer the energy and also absorbs the energy. That is called open system. And what is meant by closed system? It transfers only energy. It does not matter. Okay, it transfers only energy. It depends upon the both energy and matter. It depends upon only energy. Does not matter. That is called closed system. For example, we take the one cup of coffee, hot cup of coffee. It is closed with one lid. It transfers the energy and absorbs the energy, but there is no exchange of the matter. That is called closed system. And third one, isolated system. Does not transfer of the energy, neither energy nor matter. The system neither energy nor matter exchange between the surroundings is called isolated system. So a best example, thermoflask. It is insulated non-porous flask. That is called thermoflask. That is the example of the isolated system. And next one, homogeneous. What is a homogeneous system? What is a heterogeneous system? What is a homogeneous? What is a heterogeneous? What is a homogeneous? It contains only one phase. It contains two or more phases. It contains two or more phases. That is called homogeneous, heterogeneous. For example, in the homogeneous, pure solids, pure liquids and mixture of the gases is examples of the homogeneous. And heterogeneous, water is the best example of the heterogeneous. That is the solid ice, liquid water, and third one gases, liquid gases. So this is a heterogeneous system. It contains two or more phases. In the water system, it contains three phases, 1, 2, 3. And solid is the one phase, liquid is the one phase, and gases is the one phase. Finally, the water contains the three phases. So that is called heterogeneous system. It contains only one phase. Phase means the same physical and chemical properties. Identical physical and chemical properties of the system is called phase. Clear? And now I will start about the thermodynamic properties. Thermodynamic properties. Properties of thermodynamics. Properties of thermodynamics. Properties of thermodynamics. Okay, and here the first one is the state functions, state variable. State functions are state variable, state function or state variable or state system. That is the one of the property, state property, that is the state functions or state variable. So what is meant by state functions or state variable? Okay, it is the property, the system values are mainly depends upon the initial and final state. Initial and final states. That is called state functions. Here what are the examples of the state functions? Temperature, pressure and volume. These are examples of the state functions or state variable. What is meant by state functions? The thermodynamic properties. The thermodynamic property one of the thermodynamic property, that is the state function. The properties that values are mainly depends upon the initial and final states of the system. Initial and final. For example, we take the A reactants, it gives product B. This is the reactants, this is the products. It depends upon the both initial reactants and also depends upon the products. రియాక్టెంట్స్ మీద ప్రొడక్ట్స్ మీద రెండింటి మీద డిపెండ్ అవుతాయి. ఆ ఫంక్షన్ ఏమంటారంటే, ఆ సిస్టమ్ని ఏమంటారంటే స్టేట్ ఫంక్షన్స్ ఆర్ స్టేట్ వేరియబుల్ అంటారు. క్లియర్? ద థర్మోడైనమిక్ ప్రాపర్టీస్ దట్ హూస్ వాల్యూస్ డిపెండ్స్ అపాన్ ది ఇనిషియల్ అండ్ ఫైనల్ స్టేట్స్ ఆఫ్ ద సిస్టమ్ is called state function or state variables. And examples is the temperature, pressure, volume. Clear? Here the A is the reactant and B is the product. If the system depends upon the reactants and products, if the system depends upon both reactants and products, that is called state function or state variable. Here the state function and examples is the temperature, pressure and volume. Clear? And next one, path functions, second one. Path functions are path variable. So what is meant by path function? Here mainly that in a system, the thermodynamic property of the system mainly depends upon the path. Depends upon the path. For example, we take the reactants A and give products B. This is the reactants and products. That depends upon the path. This is the path. A to B. Conversion of the A to B is called path. But here, that depends upon the reactants and products. But here, depends upon the direction. Depends upon the path or direction. That is called path functions. Okay, path function. Here, the path function examples are the work and heat. Work and heat. These are examples of the path functions. Clear? So what is meant by path functions? The thermodynamic properties that whose value depends upon the path or direction is called path functions. Here A to B, here A is the reactant, B is the product. That depends upon the A and B is called state functions. The conversion of A to B that depends upon the direction or path is called path functions. Okay, and next one, third one, extensive property. Extensive property. Extensive property. What is meant by extensive property? Here the property is mainly dependent upon the dependent of the matter. Dependent of matter. The property whose substance depends upon the total amount of the matter or total amount of the mass or total amount of the substance. Clear? Here thermodynamic process, okay, here thermodynamic process is mainly dependent of the matter. It depends on the matter. Simply it depends on the matter. That is called extensive property. Extensive property. Clear? Once again, so what is meant by extensive property? The thermodynamic process here thermodynamic properties of the substance depends on the total amount of the substance or total amount of the matter or total amount of the substance is called extensive property. Simply it depends upon the matter. Depends upon the matter. And examples of the extensive property: mass, volume, okay, enthalpy, internal energy, Gibbs energy, heat capacity. These are all examples of the extensive property. In the IP point of view, that question is state and explain about the extensive and intensive properties. There is a 4 marks question in the thermodynamics. Last year question, that is the explain about the extensive intensive properties. So what is meant by extensive property? It mainly depends upon the total amount of the substance. The thermodynamic process of the substance is mainly depends upon the total amount of the substance is called extensive property. It mainly depends upon the matter or mass. That example is the mass, volume, enthalpy, internal energy, Gibbs energy and heat capacity. Okay, and fourth one is the intensive property. Fourth one is the intensive property. Intensive property. Here, dependent of the mass or matter. Here, independent of the mass or matter. Independent of the mass or matter. Thermodynamic process of the substance which does not depends on the matter or mass is called intensive property. Clear? Okay. So what is the intensive property? The thermodynamic process of the substance which does not depends on the matter or substance or mass is called intensive property. Examples of the intensive property. What are the examples? Temperature, pressure, okay, density, boiling point, vapor pressure, surface tension, viscosity. These are all examples of the intensive property. Okay, it depends on the mass or substance, matter, independent of the mass or matter. Clear? So this is the properties of the thermodynamic properties. One is the state function, path function. One is the state function, state variable, and second one is the path function, and third one extensive property, and fourth one intensive property. So what is the state function, state variable? Here the thermodynamic property whose values depends upon the initial and final states. That is the example temperature, pressure, volume. Here the path function, the thermal properties whose values depends upon the direction or path is called path function. Here the examples work and heat. And here the extensive property, the thermodynamic process of the substance which depends upon the total amount of the substance. Simply total amount of the depends on the total amount of the substance is called extensive property. An example, mass, volume, enthalpy, internal energy, Gibbs energy, heat capacity. And here the intensive property, here the independent of the mass or matter. Here the depends upon the does not depends upon the total matter of total substance. The thermodynamic process of the substance which does not depends upon the total amount of the substance is called intensive property. And here the examples temperature, pressure, density, boiling point, vapor pressure, surface tension, viscosity. These are all properties of the thermodynamics. Okay. And next one, thermodynamic process. Next one is thermodynamic process. Next one, thermodynamic process. Thermodynamic process. In this thermodynamic process, first one is isothermal process. Isothermal process. So what is meant by isothermal process? The process in which the total in the procedure of the isothermal process constant temperature. At constant temperature. The process is total isothermal process occurred in the at constant temperature is called isothermal process. So we write the delta T is equal to 0. We write delta T equal to 0. So what is meant by isothermal process? The process in which temperature of the system, there is no change in the total process of the studies. ఈ isothermal process జరుగుతున్నప్పుడు కంప్లీట్ గా అక్కర్ అవుతున్నప్పుడు the total isothermal process is occurred in the at constant temperature. So delta T is equal to 0. At constant temperature there is no change of the temperature. For example, A is the reactant, B is the product. A is the reactant, B is the product. This is the reactants and this is the product. Okay, here the A reactant temperature is the T1 and B temperature, product temperature also T1. So any change in the temperature? No. So in this total isothermal process, the process is occurred at constant temperature. Okay, the process in which the temperature of system is no change in the total process studied. ఈ ప్రాసెస్ చదువుతున్నప్పుడు ప్రాసెస్ నేర్చుకుంటున్నప్పుడు టెంపరేచర్ ఏ విధమైన చేంజ్ లేకపోతే దాన్ని ఏమంటాం ఐసోథర్మల్ ప్రాసెస్ అంటాం. ఓకే, సో వాట్ ఇస్ ఐసోథర్మల్ ప్రాసెస్? దిస్ ప్రాసెస్ ఈజ్ అకర్డ్ ఎట్ కాన్స్టెంట్ టెంపరేచర్ is called isothermal process. That is the delta T is equal to 0. Here the A2 convert to B, here there is no change of the temperature T1. Okay, and next one, second one, adiabatic process. Adiabatic process. So what is meant by adiabatic process? So the process at which the process is occurred at constant heat. Okay, here the heat flow between the system and surroundings, there is no change. So the process is occurred at constant heat flow is called adiabatic process, or the process in which exchange of the heat flow between the system and surroundings does not take place is called adiabatic process. So here the Q is equal to 0. Here the Q is equal to 0 is called adiabatic process. So what is meant by adiabatic process? The process in which the exchange of heat flow between the system and surroundings does not take place is called adiabatic process. Simply, the process is occurred at constant heat flow is called adiabatic process. Clear, Nana? And third one, isobaric process. Third one, isobaric process. So, what is the isobaric process? What is isobaric process? The process in which at constant temperature, here the pressure is constant. Pressure is constant. The process occurred at constant pressure is called isobaric process, or the process in which the pressure of the system does not take place. The pressure of system does not take place is called isobaric process. So, here the delta P is equal to 0 is called isobaric process. This is called isobaric process. And next one, fourth one, isochoric process. Fourth one, isochoric process. Isochoric process. So, what is meant by isochoric process? The process in which at constant volume, the process is occurred at constant volume is called isochoric process, or the process in which the volume of the system does not take place. There is no change in the volume is called isochoric process. So, delta V is equal to 0. Okay. Here who is the constant? At constant volume. At constant volume is called isochoric process. So, once again I will repeat it. So, what is isochoric process? The process in which the volume is there is no change in the volume. The entire process is called isochoric process. So, the process is occurred at constant volume is called isochoric process. And last one is the cyclic process. Cyclic process. So, what is meant by cyclic process? Here the process is occurred. Okay, here the process is occurred. The initial system revert back to the some operations is called cyclic process. So, for example, we take the system A, it is converted to B, okay, B is converted to C is converted to D, and D is converted to A. Here A is the initial state, and final state also A. Here the initial and final states are same. Here initial and final states are same is called cyclic process. What is the cyclic process? Here the initial and final states are same. The process in which initial state is regained after some operations. How to regain the system A? Here the A is converted to B, and B is converted to C, and C is converted to D, and finally we get the D is converted to A is called cyclic process. In the cyclic process, internal energy delta U is equal to 0, enthalpy delta H is equal to 0. Here the both are constant, internal energy and enthalpy both are constant. So, delta U is equal to 0, delta H is equal to 0. So, what is the cyclic process? The process in which the initial state regain after some operations is called cyclic process. Okay, once again I will repeat total thermodynamic process. So, what is the isothermal process? The process in which the temperature of the system does not take place is called isothermal process. The process is occurred at constant temperature is called isothermal process. Here delta T is equal to 0. And next one, adiabatic process. At constant heat flow means the process in which The exchange of heat flow between the system and surroundings does not take place is called adiabatic process. So Q is equal to 0. And next one, isobaric process. So what is the isobaric process? Here the pressure is the constant. The process in which the pressure of the system does not take place, the entire total procedure is called isobaric process. So delta P is equal to 0. And isochoric process. So what is isochoric process? Here at constant volume. The process in which the volume of system does not take place, entire procedure is called isochoric process. So delta V is equal to 0. What is the cyclic process? The process in which initial state of the system regain after some operation. So how to get one operation? This is one operation, and second operation, and third operation, and fourth operation. Here we get the initial state of the A. We get the 4 operations, means A to B, B to C, C to D, and D to A. Finally we get the A. Here the initial and final states are same. Okay, we take the A and finally we get A. So here the initial A and final also A. So here the internal energy and enthalpy both are constant. So delta E is equal to 0, delta H is equal to 0. This is the today class thermodynamic process. Next దానికన్నా ముందు ఏం చెప్పుకున్నాం, థర్మోడైనమిక్ ప్రాపర్టీస్ చెప్పుకున్నాం. సో వాట్ ఆర్ ద థర్మోడైనమిక్ ప్రాపర్టీస్ చెప్పుకున్నాం, ఎక్స్టెన్సివ్ ప్రాపర్టీస్ చెప్పుకున్నాం, ఇంటెన్సివ్ ప్రాపర్టీస్ చెప్పుకున్నాం, స్టేట్ వేరియబుల్స్ చెప్పుకున్నాం, పాత్ ఫంక్షన్స్ చెప్పుకున్నాం. సో వాట్ ఇస్ ద స్టేట్ ఫంక్షన్, వాట్ ఇస్ ద పాత్ ఫంక్షన్, వాట్ ఇస్ ఎక్స్టెన్సివ్ ప్రాపర్టీ, వాట్ ఇస్ ఇంటెన్సివ్ ప్రాపర్టీ, వాట్ ఇస్ ద స్టేట్ వేరియబుల్స్, వాట్ ఇస్ స్టేట్ వేరియబుల్స్. Okay, here the initial and final states are same. Why get that is the state variables. That is the temperature, pressure, volume. Path function. What is meant by path function? Here the reactants convert into products. You follow the one direction. Our path is called path function. Okay. And next, what is the next extensive property? What is the intensive property? Here the extensive property. The property which depends upon the total amount of the substance is called extensive property. That is the mass, volume, internal energy, heat flow, Gibbs energy. These are all examples of the extensive property. But what is the intensive property? The property which does not depends upon the total amount of the substance is called intensive property. Okay, that is the example. What are the examples of temperature, pressure, surface tension, viscosity? These are all examples of the intensive property. That is the thermodynamic properties. That is the state variables, state function or path function, and third one is extensive property, and fourth one intensive property. That is 4 are thermodynamic properties. And next one, thermodynamic process. That is the isothermal process, adiabatic process, isobaric process, isochoric process, and cyclic process. This is a today class. Tomorrow I will continue. Thank you, students.